every square meter of this building must comply with the plans. Unfortunately, the reality on the building site rarely matches the technical drawings perfectly. The question is, how quickly can this be checked? And is the FJD Trion S1 SLAM scanner sufficient for detecting errors? That is exactly what I have investigated. The building is a multi-storey cultural library, a building currently under construction. Our task was to compare the design dimensions with the actual dimensions. In other words, to carry out a quality control check on the construction work. I used two tools, the FJD Trion S1 mobile SLAM scanner and the Faro Focus M70 stationary face scanner. There was one objective, to check whether a faster mobile SLAM scanner could detect the same errors as a high-precision stationary scanner. Faro Focus M70 is a terrestrial scanner with an accuracy of 3 mm within its operating range. It is a professional, tried and tested device. However, working with it requires discipline and time. I had to set up the scanner at numerous locations on each floor, wait for each scan to finish, move the equipment around, and record the point clouds. All in all, almost a whole working day on the building site. The result? A dense, precise point cloud, but it took a long time. FJD Trion S1 takes working to a whole new level. It's a mobile SLAM scanner. I just put it on and walk around. No tripods, no waiting, no breaks between stations. Scanner records 320,000 points per second, whilst the real-time SLAM algorithm builds a point cloud on my mobile device. I don't waste any time. I scan on the move, across all floors. The entire multi-story building, 40 minutes. That's not a mistake. Once the data had been collected, it was time for the analysis. I registered both point clouds in a reference system and compared them with the design model. The result is a visualization of the construction deviations. Faro Focus M70 terrestrial scanner, a benchmark for accuracy, revealed a series of deviations from the design. In several places, the walls were out of tolerance, the ceilings were uneven, and the door openings differed in size from the design. The FJD Trion S1 showed fewer deviations, which is to be expected, given that its relative accuracy is 2 cm compared to the Faro's 3 mm. However, and this is crucial, all the critical manufacturing errors detected by the Faro were also identified by the Trion. The deviations were large enough that the SLAM scanner's inherent error did not interfere with detection. Each step of the staircase had a slight but consistent difference in height. This effect accumulated to a deviation of 10 centimeters over the entire floor. Such an error is evident in every scanner. What does this mean in practical terms? Faro Terrestrial Scanner is an inspection tool offering millimeter-level precision, essential for technical acceptance checks, as-built documentation, and analysis requiring absolute accuracy. But FJD Trion S1 offers something that Faro doesn't: real-time monitoring of the construction site. 40 minutes instead of a whole working day makes a real difference. This means that such inspections can be carried out every week, rather than once a quarter. SLAM does not replace TLS, it complements it. And it is precisely this synergy that holds the key to the future of quality control on construction sites. FJD Trion S1 has demonstrated that the speed and accuracy required to detect workmanship defects can go hand in hand. It is a tool that is transforming the way we view quality control on a construction site, not as a one-off, costly measurement, but as a regular, rapid and accessible process. The universe has been measured for centuries. We measured this building in 40 minutes.